In this section, we're going to see where the number e comes from. The number e has a few different names. It's called Euler's number sometimes, other times it's called the natural number, and it has many different strange appearances and properties. The place that we're going to look at where it appears is compound interest. So let's go ahead and remember what our compound interest formula is. This is given by a of t is equal to p times 1 plus I divided by n raised to the n times t. Let's go ahead and let I be an 100% interest rate. Which is going to translate to I being equal to 1. And let's also allow our time period t to be equal to 1 time unit. Our new compound interest formula is going to be given by p times 1 plus 1 divided by n raised to the n power. Recall that this number n is the number of times that we compound our interest per year. Let's go ahead and plug in some numbers for n and see where this number is heading to. All right, let's go ahead and draw the chart. N is going to be our input, and we're plugging it into the function 1 plus 1 over n raised to the n. Let's look at 1, 10, 100, 1,000, and also 1,000,000. Plugging 1 into our formula, we're going to get 1 plus 1 raised to the 1. This is going to be 2. Plugging 10 in, we're going to get 1 plus 1 over 10 raised to the 10. This is approximately equal to 2.59. Continuing on. Our next number after we plug it in is approximately going to be equal to 2.704. Plugging into 1,000 to this equation, we'll get 1 plus 1 divided by 1,000 raised to the 1,000th power, which is approximately 2.716. And if we plug in 1,000,000, we're going to get approximately 2.718. What we're seeing is that as n grows infinitely large, we're getting that 1 plus 1 over n is approaching some number that's about 2.718, so on and so forth. We can't write out the list of numbers over here, and the reason why is because this number is infinitely long in the decimal place. But what we can say is that our output values are approaching a number, and in calculus, this idea is called convergence. So what we say is that the number e is defined to be the end of this convergence. The number e is then defined to be the following. So the convergence of the function 1 plus 1 over n raised to the n is the number e, as we have that the values of n approach infinity. While we can't really define this without the use of calculus such as limits, this is going to be our working definition, and usually when doing computations, you can more or less approximate e to be 2.718 and maybe a few more digits if you need more accuracy.